and welcome everyone to our webinar today, The Road to Real-Time Insights with Spireon. Today, you'll be hearing from Dave Withers, Director of Analytics at Spireon, who will be sharing how they established their data management strategy to move towards real-time insights. After, we'll get a brief overview of Snowflake from Harsha Kapre, Product Management with Snowflake, and an overview of Alooma from Daniel Ben-Yosef, Manager of Solutions Engineering. We'll then wrap things up with a Q&A session at the end, so please submit your questions. Before we get started, though, if you have any technical issues during today's broadcast, please let us know via the question box on the side of your screen. This window is also where you can submit your questions for our speakers. I'll be keeping track of these for our Q&A session at the end. Last, if you miss anything, please don't worry. We are recording today's webinar, and we'll be sure to send that out via email, so keep a lookout for that. Now for our presentation, The Road to Real-Time Insights with Spireon, I'd like to hand things over to Dave.
Thank you, Diana. I'm very glad to be here, and I appreciate Alooma and Snowflake's invitation to share with you all my experience leveraging their solutions. I'd also like to extend thanks to everyone on the line for your attendance today. The promise of software as a service offerings for us was to gain leverage in hopes that our smaller team could operate with the scale and efficiencies of a larger one. As the great mathematician Isaac Newton had said, standing on the shoulders of giants. And in starting you all off with that thought, please allow me to introduce myself. My name is Dave Withers. I'm the Director of Analytics at Spireon. I've worked in database and analytics roles for over 20 years. Come to Spireon from Microsoft, where I'd worked on the SQL Server research and development team for their parallel data warehouse product. While there, I'd gain an appreciation of the complexities and costs in dealing with data at scale. I found that big data, at first, is only an abstract buzzword until you're faced with massive amounts of data needing to be processed in real time as a requirement of your daily operations. I'd seen firsthand that the traditional model of scaling up hardware to bigger and beefier CPU, memory, and disks ultimately reached breaking points faster than our budget can often afford, let alone having to wait on Moore's Law to catch up to make the technology available. It's from that perspective that I bring an awareness of needing to avoid vertical scaling only solutions when dealing with data at Spireon. So today we'll be covering managing data complexity when integrating data, addressing data growth that will quickly surpass the storage and compute limitations. And as well, we'll cover accessing real-time insights from data across multiple sources. So who is Spireon? Spireon is North America's leading connected vehicle intelligence company. Spireon provides visibility and insights from connected vehicles to help businesses run smarter and for people to drive safer. We are both an IoT hardware manufacturer and a robust software platform that supports nearly 4 million active subscribers across a growing suite of products for new and used car dealers, financial institutions, rental car agencies, fleet operators, and consumers. Our devices generate over 1 billion data events a month and is growing exponentially. This accumulation represents over 360 billion recorded driving miles, or the equivalent of a single vehicle driving 15 million times around the planet. Our products enable such rich features as allowing companies to know in real time if pickups are on schedule to maximize asset utilization, or providing car dealerships the ability to locate vehicles across car lots, or providing consumers the ability to monitor their vehicles in and out of geofences. These are just to name a few of Spireon's innovative offerings made possible by our enriched telematics data. So now that I've introduced myself and Spireon, let me share with you the challenges we've been facing at Spireon and why we ultimately turned to Alooma and Snowflake for help in solving them. Some of the critical challenges we saw were semi-structured data with unpredictably changing attributes. Our being an agile development shop, we make use of semi-structured data formats such as JSON quite heavily, as it provides fast time to market for developing new features without needing a DBA to make structural changes. While this has been a vital benefit for us, managing the dynamic format was not without its complications. Large payloads from our devices. We have over 280 attributes that we track on a data record from our devices. Any of these may need to be queried upon or aggregated by. So what this means is there are 280 ways things can go wrong per data record from our MongoDB store to our data warehouse. Some of the compute limitations for querying existed because we first attempted to vertically scale up our hardware to address the querying needs of our customers, only to realize our systems reached computational and memory limits or budget limits. The resulting query performance did not meet our customers' low latency expectations despite our having added larger, more expensive hardware. And adding insult to injury, we had our data stored on individual servers, which meant we were having to increase storage volumes at an unmanageably expensive rate to ensure we had proper high availability and disaster recovery guarantees. With these big data challenges confronting us, my team set the goal to advance our data management infrastructure to enable real-time insights for our growing base of 40,000 customers. To achieve this goal, the challenges we sought to overcome were streamlining the data ingestion process as top priority. We could not provide any features or insights without a reliable and efficient means to get our data into the warehouse. Minimizing storage costs. The exponential costs of managing and maintaining our data was a critical factor for our executive management, which needed to be addressed. And finally, scale data querying. Once we had the data where we needed it, we required a platform capable of scale and providing results from complicated SQL queries against data sets that could reach well over 40 terabytes in size. So challenge one for us was data complexity when integrating our data. To address this most critical challenge of integrating the complex and dynamic JSON data set, we had to factor that JSON was a semi-structured data format which allowed for data nodes being added to, removed from, or having nested arrays, a set within a set. These made translations to an equivalent structured format problematic. We also needed the ability to guarantee the ability to add new attributes in our data records that represented event types or other unexpected schema changes over the course of future development. All of this flexibility of our development team, provided by the JSON format, conflicted with our relatively inflexible ETL processes, performing data transfer, transformation, and batch aggregation. Ultimately, a JSON source meant our data ETL was wrought with potential support pitfalls and service disruptions. This inhibited our ability to smoothly manage development changes to the data schema. So our original solution was to build a data pipeline in-house. Our data team sought to address the challenge by leveraging an in-house Java application. Over the course of months in development and testing, we found this prone to errors due not only to JSON, but other unforeseen issues with the incoming data itself. We'd seen nested arrays, non-Unicode data, malformed dates, and various other data mutations which broke the application's ability to sustain a continuous pipeline. To say this was resource and labor intensive would be an understatement. Ultimately, the team determined the in-house solution would not scale to meet our data pipeline goals. So our new solution was with Alooma automated data pipeline. And learning from these pains, we had researched different SaaS offerings in the Amazon marketplace and found Alooma to hit our needs quite squarely. Their solution helped our team find a stable tool to operationalize our data pipeline from JSON source to data warehouse destination. Their Alooma mapper auto-detects incoming data attributes and infers data types from the JSON. The mapper was able to handle 80% of our cases with automation. For the remaining 20% cases, Alooma was able to handle exception, and we were able to manually perform the mapping ourselves. Their code engine was a function that let my team write custom Python code to scrub and enrich our ingestion data on the fly or during the transform phase of ETL. The restream queue took care of exceptions we'd encountered during ingestion, and it was exactly where we had struggled the most in our in-house solution. The restream queue catches errors in the real-time stream, sends it to a queue for resolution, sends notifications, and also allows operators to restream the data once the exception is addressed. And finally, Alooma has native Snowflake data type support. This ensures that the data types would not have conversion issues at the final destination. The combination of auto mapping, custom transformation, exception handling during transformation, and this native data type support helped my team address complications with having a dynamic JSON source. So for challenge number 2, we had to address the data volume and compute limitations. Left unattended, data growth at some point exceeds any infrastructure's capabilities and may have catastrophic effects on the business. We found this point early on in trying to leverage our MongoDB operational data store for the purposes of both transactional and reporting roles. My team found that the MongoDB restrictions of limited indexing and the need to keep those indexes continually persisted in memory caused performance issues for read and write queries, especially when approaching storage and memory limits. Lacking clairvoyance and struggling to anticipate an appropriate amount of CPU and storage needed, the field surprise spikes in our user activities left us to the mercy of those kind of cycles. In fact, once capacity would approach certain limits, our MongoDB server nodes would routinely fail over, keeping my DBA team in a scramble to solve the resulting production issues. So the original solution for our team was to add Redshift as a data warehouse. As this was an obvious supportability issue, we had to separate the MongoDB operational data access from our reporting access by replicating data to an Amazon Redshift data warehouse cluster. And for a while, this had addressed our needs pretty well. But after about a year and a half, we again approached scaling limits in our data infrastructure. Worse, in order to enjoy cost discounts on Amazon Redshift, we had to anticipate our needs about a year to 3 years out in advance, depending on the reserved instance period. And for us, the first year, we were under the estimated allocation. But by the second year, we grew faster than the forecast. Because of this, we faced a 10x infrastructure cost increase to address the immediate 2x growth needed in our data storage. At this point, we looked to other solutions on the Amazon AWS cloud and found Snowflake Data Warehouse. They offered a solution separating server compute from data storage. This meant we were no longer tied to long-term forecasts of hardware for scaling. We didn't need to be conservative to account for maximum or peak load as something we had to provision at that point and stay with for an entire year or 3 years. Also, Snowflake had additional benefits above our original Redshift solution. For instance, S3, Snowflake charges the at-cost rate for data storage on AWS S3. Adding in the benefits of compression, data costs became a smaller percentage of our overall solution costs. Snowflake has compute clusters. We had the ability to scale on these compute clusters as high as the largest Amazon instance type. This meant, if needed, we'd have a vertical scale for our growth on any given compute cluster instance. Also, these compute clusters, or as Snowflake calls them, data warehouses, suspend and resume automatically. You only pay for what you use. Snowflake makes great use, or the platform is built on massive parallel processing, which ensures we can always reliably leverage parallelism and be assured query performance that meets our customers' needs for spikes in user demands for even the most intense query jobs. Automatic scaling and multi-clustering. This allows multiple clusters to be spawned to handle any potential concurrency or queuing issues due to a possible resource bottleneck on any one compute cluster. The option scales horizontally, or in other words, adds additional compute nodes to the mix automatically, which assures reliable and predictable growth. And finally, for challenge 3, real-time insights, to accomplish this, we had to have a complete system factored to minimize latency everywhere in the process flow, beginning from when a device data payload lands in our MongoDB operational data store to traversing our data pipeline for processing and eventual storage over in Snowflake. To manage this, we had to normalize high-volume data coming in to be as lightweight and nimble a process as possible. We had to reduce any latency in our batches or our batch processing, and in order to do this, we had to simplify it, or in other words, not having any massive lookups of million-row dimension tables within the data pipeline. And finally, we had to manually recluster our data. For Snowflake, we had to be sure that the data would be local to a server compute cluster as the data became available. This meant manually issuing reclustering commands for tables on Snowflake to limit any potential for unnecessary latency. In later releases on Snowflake, this became an automated process, and the feature came in without any change or any disruption of service. The pairing of Alooma and Snowflake with their cloud-based infrastructure brought us closer to real-time insights. Alooma's dedicated team helped us continually improve our process of data normalization and augmentation while addressing source data ingestion complexity. Snowflake provided the horsepower to meet the needs of real-time queries against terabytes of new data monthly for us. From all of this, the factors of concurrency, cost, maintenance, and minimized data latency became a strength of our solution. So in summary, what I hope you gleaned from what I've shared today, here's some key takeaways coming from an elated Alooma and Snowflake customer. Alooma provided my team an automated data pipeline with real-time processing and native data file format support for JSON and others to match even our most complex data source ingestion requirements. Snowflake gave my team a cloud data warehouse solution with the valuable separation of compute from storage. This paradigm enabled linear scalability, or what we had originally envisioned the benefits of cloud scale to be. And to make my long story even a bit longer, the fully managed, built-for-the-cloud solutions by Alooma, paired with Snowflake, revolutionize our big data analytics capability at Spireon. These tools sped up our development time to market, allowed my data team to focus on the company's core value proposition of producing innovative, accurate, and timely insights out from our over 4 million connected car devices. Thank you very much for your time today. I'll turn this over to Daniel.
Actually, this is Harsha, so I think I'll take the Snowflake piece from here, so thanks, Dave, for that. Just a quick reminder, my name is Harsha Kapre. I'm a product manager here at Snowflake. I cover the partner ecosystem, so I do everything from the drivers and clients to engaging with our partners like Alooma on making sure we have kind of optimized connections and are really providing the best experience for our customers. So I'll do just a couple minutes on a quick overview of Snowflake to cover some of the points that Dave already mentioned. But just to reiterate, kind of why Snowflake was built in the first place. It's really because when our founders got together, they looked at what was out there and said, the data analytics problems, really hadn't been addressed yet. And, despite the promises of big data solutions that were, hitting the market, everything was still kind of based on a traditional approach of, either a shared disk approach or a shared nothing approach, whether that was on-premise or even some of the cloud solutions that first evolved, still were kind of taken from on-premise and moved to the cloud. The issue with these traditional approaches, and Dave highlighted some of this in his talk, is compute and storage are still coupled together and tightly integrated, right? So if you want to scale up, scale down instantly, like what we talked about earlier, you really can't do that with those traditional approaches. With shared disk, you've got one disk, you've got to add compute on top of it. With shared nothing, you've got to redistribute the data. In both of these cases, you can't do independent scaling, you can't do workload isolation, and you're really limited into how much and how far you can go. And as Dave said, that what ends up happening is you have to really plan, quite a bit out, a year or more, in terms of understanding your infrastructure needs and costs. So with Snowflake, our founders focused on a brand new architecture, and they really wanted to solve the problems they were seeing that really hadn't been solved with siloed data, with lack of flexibility. And they came up with a new approach, which was really starting with what the cloud offered and building Snowflake from scratch in the cloud. So they didn't take anything that existed already. They started with something brand new, and it all started with flexible cloud storage. So originally, with our AWS deployment, it all started with S3. Now with Azure, we also have the ability to cover the exact same deployment using Azure Blob Storage. But starting with that flexible cloud storage, they built on top of that a services and SQL layer that handles all of the services you see here, the management optimization. I'll talk a little bit about that on the next slide. But in terms of the architecture, the idea was that storage and compute were completely separate. So using EC2 instances for the compute clusters, the idea is this notion of what we call a virtual warehouse. These virtual warehouses can be spun up independently and have no contention. So the idea behind all of this was really workload isolation, right, and dealing with concurrency. So as you can see in the diagram here, you can have a virtual warehouse that's listed here in the top left that says under data science. These are sized, we use t-shirt sizes, so small, medium, large, extra large. I think we even have extra small. And those all map to the number of nodes in your cluster, right? So you can have one cluster set up specifically for your data science team. In this case, we're using a large. You can have a separate cluster that's a small set up for your ad hoc queries, another cluster set up for your data transformation or your ETL processes, a fourth cluster set up for your BI and reporting. The key takeaway from here, though, is that with this separation, you can have all these workloads running simultaneously with no contention. So in the old days, and many of you guys may be even still experiencing this today, you have all these ETL jobs, and as the amount of data is growing, you're saying, oh, well, I better run my ETL jobs at, between midnight and 5 a.m. so that it's not affecting my business users, right? But, the globalization, and as, more and more, people are bringing workforces on from other countries, now all of a sudden you have business users in all the time zones, so you can't really, model that any longer with that, by a scheduling solution. So with Snowflake, you can have a completely separate compute cluster running for ETL processes 24 hours a day. Your BI and reporting team can come on at all hours of the day and have no contention at all for resources. And that's really the key behind everything that makes Snowflake what it is. So some of the key benefits that come out of that, and just to kind of highlight the value prop. So number one, Snowflake is a complete SQL database. So that means it works with all of the business tools that you have today. So, depending on what your BI tools are and data science tools, et cetera, everything will work out of the box through our standard JDBC, ODBC, various set of connectors. It's fully ACID compliant and a fully relational database, role-based security, multi-statement transactions, all the other features you'd expect. The zero management piece is a key feature that when we say zero management, we mean load your data, run your queries, we'll take care of the rest. There's no infrastructure admin costs. It's highly available. It's automatically scaled out across regions and across VPC, or not VPCs, but availability zones within AWS, and the same concept in Azure. There's no knobs or tuning required. There's no indexes, distribution keys, anything like that. So there's really no maintenance at all. The point about all your data is both semi-structured and structured data. So Dave made the point of JSON data, right? So JSON, XML, Parquet, Avro, all of that can be natively ingested in Snowflake. You don't need to do any additional transformations on top of it. Everything in Snowflake is about centralizing your data, making it accessible to all of your users all of the time. And on that point of all your users, the whole notion of what I talked about on the last slide of separating out your workloads, there is no contention, right? So if you have 100 users today and you want to add another 100 users tomorrow and 1,000 users next week, you simply spin up additional compute clusters to handle that load and balance the contention. So virtually unlimited concurrency. Pay for what you use. All these virtual compute clusters or these virtual data warehouses auto resume and auto suspend. So if there's no queries, they'll turn themselves off. As soon as a query comes, they'll turn themselves on. We charge per second, so you really get down to a very granular notion of how much you pay and what you pay for. And then the last point, just to kind of highlight a really interesting benefit of Snowflake and something you'll probably be hearing a lot more about is our concept of live data sharing. So the notion here is you have two Snowflake customers, and because everything is in the cloud, we can manage through secure views instantaneous data access between those two customers. So the concept of a provider and a consumer, you have a provider who today is doing some kind of FTP, ETL job, trying to get the data out, send it over to their consumer. Now with Snowflake, they can create a secure view, click on a data share, identify using an account identification, and that consumer will instantly see that data show up in their system. Any of the processing that they do will be charged against their compute clusters, but the data is only stored in one place and only charged to the provider. So it makes it really easy to start sharing data between providers, consumers, partners, and you'll start to hear a lot more about data sharing as it's a big focus for us now. So I know I spoke fast, trying to go quickly, but with that, I'll turn it over to Daniel at Alooma.
Thanks, Harsha. This was really cool, as always. Okay, so I'm here to talk about Alooma. I'm going to be very, very quick about it as well. What is Alooma, essentially? What are our highlights? What differentiates us from other contemporaries? So essentially, Alooma is your data pipeline as a service. It is running in the cloud, is a hosted service, pretty much the same as Snowflake in that case. Sorry, there we go. And a little bit about what we do, what differentiates us. So Alooma is a data pipeline where you can connect any source. You can stream it to Snowflake. And we offer a flexible, secure way to sort of extract data. So think about all your ETL flows that you use to write, or either write mapping manually, or take care of error handling yourself. All of those workflows have been fully automated for you already out of the box. So I would connect anywhere between a sharded Mongo cluster that's running either on Atlas or any other services, or if I want to migrate my Oracle or SQL Server data or MySQL or Postgres, if I have something on-premise, I want to migrate it into the cloud, into Snowflake. That's something that Alooma can automate for you, running either stuff like CDC or ODBC incremental querying, or even full dump batch loads for lookup tables or anything of that sort. If anything fails, obviously there's alerting, there's auto-handling mechanisms that will basically tell you what's happening in your pipeline. It's as if you've written your own custom data pipeline in-house but you don't have to run it, you don't have to manage it, and you don't have to monitor it at all. Those are sort of some of the main highlights or the things that we like about Alooma. Sort of what this looks like, or high-level architecture, right? So you have your sources. We would take that out of those sources. We would auto-map. So we have an auto-schema detection and inference component that essentially looks at the data or looks at the source if it's a relational database or a SaaS API that might have a schema export service, excuse me. We would take that data, we would map it, and essentially create all the DDLs, all the tables accordingly, respond to schema changes during an event or to type of data life cycle. And that applies to both the RDBMs again and the SaaS APIs, as well as semi-structured data sources such as Mongo. One of the nicer things that I actually like about working with semi-structured data as well as with Snowflake is the native support for semi-structured data or schema on read. So if we're talking about Snowflake, things like the variant type, so that's actually automatically supported, which means that if the mapper or the Alooma classifier would see something in the data that's semi-structured, if it's coming from Mongo, if it's coming from SaaS APIs, if it's coming from things like S3 or even SFTP, if you have something from there, Alooma will auto-infer those types and we'll see this is semi-structured data, and will automatically create a variant type within Snowflake, which, as Dave mentioned earlier, makes it really easy to work with the data afterwards. A few other highlights in Alooma. We're SOC 2 Type 2 compliant. Everything is secure. Everything is encrypted both at rest and in transit. Again, the error handling, we have something called the restream queue, which is our error handling method, which will hold the data basically for you if we couldn't load to the data warehouse, or if for any reason the transformation code was broken and we couldn't load to data warehouse, or even to something like S3 or Azure Blob Storage. The data will be waiting for you. You won't have to fetch it again. If we go back here, that's it. You don't have to develop anything really. So as mentioned, all the connectors are pre-built for you. And if you have something that you're doing internally, if there's a web service or server log data that you'd like to send over as well, those are available to you, either through native language SDKs or things like a webhook that essentially instantiates an HTTPS endpoint for you to hit in JSON form. That is it. Thank you.
Great. Thanks, Daniel. And for the audience, if you haven't done so already, please submit your questions in the question box, and we'll try to get to as many as we can today. So it looks like we have a few already in here, so let's get started. This first question looks like it would be for you, Harsha. The audience member asked, you mentioned auto-scaling the compute clusters with Snowflake. Is that fully automated, or how does that work?
Yeah, thanks for that question. So auto-scaling is a feature that we refer to as multi-cluster warehousing. So by default, with our standard edition, you have the ability to scale up and scale down resources, but it's manual, right? You can resize an existing warehouse from small to medium, medium to large, and you can add warehouses on the fly. With a multi-cluster warehouse, you define kind of the initial cluster size. So let's say it's medium, which I think is 4 nodes. As your cluster, and what the system will do is it'll auto-detect any queuing. So as soon as it detects that there's any queuing, it'll replicate an additional cluster. It'll warm the cache, redistribute the data automatically. So all the data is still in S3, and what we do is we essentially cache it in each of those clusters, so that makes it available, with good performance. And again, if after 2 clusters are spun up, if there's additional queuing, a third will spin up, and after some period of time, if it's not needing those resources will automatically shut off. So it's a really good solution for customers who really want everything fully automated. I think it's part of our enterprise edition.
Great, thanks, Harsha. And I just wanted to quickly remind the audience that the slides from today will be sent out via email, so keep a lookout for that. Our next question here, it looks like, is for Daniel. How fast can Alooma replicate data from MongoDB into Snowflake?
Very good question. So it usually is about 1 to 3 minutes from a moment that we detect a change or a change happens that change gets written to the MongoDB oplog, which is where we would read from, and then we would see that change, and then within 1 to 3 minutes, you should be able to already query it within Snowflake.
Great. This next one, it looks like it's for Harsha. How can we get started with Snowflake and Alooma? How easy is it to connect Alooma to Snowflake?
So it's actually very easy to get connected, and there's something that I'll do a little plug on, which is something we call Partner Connect, which is a feature in Snowflake that allows you to rapidly connect to some of our partner solutions, and Alooma being one of the first ones that joined us here. So instead of going and signing up for Snowflake and then separately signing up for Alooma and then entering your credentials and database information, what you do is in Snowflake, you click on Partner Connect, you click on Alooma. We'll automatically spin up an account for you that's pre-populated with the database, the username, password, everything you need. You go over to Alooma, you set up your data source, and within 3 to 5 minutes, you're syncing data. So that way you can get started with Alooma and Snowflake faster than almost anything out there. So it's a really cool and easy way to get started.
Awesome. Our next question here is for Daniel. What types of streaming sources does Alooma support?
Great question. So Alooma supports multiple streaming components. Like some of those would be, your classic Kafka, be it on the cloud or on-premise or even on the Confluent service, as well as sources like Google PubSub and Amazon Kinesis.
Great. The next question is, can Alooma also do batch, or is this just for real-time use cases?
Yet another good question. So Alooma can actually do both. If you take the let's oversimplify 2 use cases, right? We would have the sources that are constantly changing, right? And we do want to capture those. So let's say maybe even a fraud system as a relational database or event stream or an online ordering one. That would be the kind that I want to get constant updates on. So for those, I would try to tap on the change data capture or the streaming sources for those. And the other case where I might have some lookup tables, right? And they can be on relational databases, or maybe I'm building my star schema and I have those coming in from file sources. Those tables I would usually want to, do once a day because they don't change really often. So either once a day, once a week, but basically on a schedule. So Alooma actually supports both of those methods, depending on sort of how you want to load it or what kind of workload you're working with.
Great. Looks like we have our last question here. Does Alooma support MongoDB sharded clusters?
Yes, indeed we do. So we do support MongoDB sharded clusters, where not only we'll send it as append-only data, but we will actually be able to merge the data into Snowflake according to either your sharding key or another key from the data. So either the document ID, if you have those, or a combined document ID as well as the shard key usually. So we would tap onto all the shards, right? All the databases from all the shards, replicate the data from whatever oplog, and we usually use MongoS for those. And then we would replicate the data over and then merge it into Snowflake according to the shard key as well. So partition by the shard key. Sorry.
Great. Well, thank you, everyone, for joining us today, and thank you to our speakers. If you'd like to check out Alooma or Snowflake, we've put the links on the final slide there, so you can get started with some free credits and check us out. And today's presentation will also be shared out via email, so you'll get a recording of this presentation in case you wanted to review anything. And thank you for joining us again, and we hope you see us in the future.